Hey friends, hope you're doing well. Today I'd like to discuss with you how you can create a simple movie recommender system in Python. And for that, you only need the standard libraries, in this case pandas. And if you want to visualize something, then matplotlib or and/or Seaborn. So let's get started. So what I did was here I first imported NumPy and pandas as my libraries, and I specified column names because those are not included in my file itself. Then I read the file after uploading it to Colab, and you can see here this is the data frame output. So we have a user ID, an item ID, a rating, and a timestamp. Now, we have another data frame in here which shows us also the item ID and the title. So this allows us to bring those two data frames together because we have an item ID here and also an item ID up there. And I want to join them because the item ID here doesn't tell very much, right? We don't know the name of the movie. This is why we want to get the title also in this data frame up there. So we do this by calling pdo.merge, and we merge on the item ID because the item ID is the common column in both of those data frames. So if we say on item ID, we can simply then call the .head, and we see that we get exactly the result we want. So now we have the starting point, and we can see we have a user, and this user 0 gave a rating of 5 for the title or for the film or movie Star Wars. So far, so good. Here, in this case, I imported also the libraries matplotlib and Seaborn because I want to plot something. Just in a second, you'll see that. And then I simply created another data frame here, which I grouped the title, in this case, based on the rating. I want to have the rating column. And for the rating, I want to have the mean rating and the count. And if I show you the head, that looks like that. So this gives us now an indication. So we know this was the title. The mean rating was 2.33. And in total, we have 9 ratings for this movie. So that's why those two columns are interesting to us, because the count gives us an indication how many people have actually rated this movie. And this is important because if we have a rating, for instance, for a movie which is very high, for instance, let's say we have a 5 rating for the first movie here, but only 9 people have watched it and actually rated it, then this rating is not really a good indication, right? That's why it's important to also have a count column in here. So next, I use a join plot here to just visualize the mean and the count. And we can see here that intentionally, it looks like actually if the mean rating is higher, then also more people actually have seen it and actually rated it. So there's a tendency, which is good, actually and interesting, that actually the more people have seen the movie, the higher the rating. So next, what we create is a movie matrix here, which is a simple pivot table. We can do that using the pivot table function and use as the index the user ID. The columns are the movie titles and the values are the ratings. And this gives us then this matrix here. And you can see we got here our users. We got now all our movies in the columns. And we get then the ratings. In case they have rated the movie and seen the movie, we can then see the ratings in here. And you also see that we have a lot of NaNs, simply because the people have either not seen the movie or they have seen it but not rated it, right? So there is no rating available. Next, I was using here Star Wars. And Star Wars here, what I did was I just used one of the columns in this case, movie matrix. So I was referring to Star Wars, the movie, and this just gives me one column in here for the ratings. You can see that down here. I just plotted it here as well. And now if I want to find out which of those movies we have in here are similar to the Star Wars movie, I can simply call the core_with function. So I'm using my matrix here, my pivot table, and I'm calling the core_with, which allows me now to find, if I say core_with the Star Wars column here, so this one up there, which we created, it then calculates the correlation between the Star Wars rating to all the other columns we have in this table. And if we then just, its type is a series, but if we plot it, or actually visualize it here, you can see that we get now a title in here, and we also got the correlation. So this gives us now all the movies here and their correlation to Star Wars. And the correlation can go from -1 to 1. And -1 means there is actually a negative correlation. So if someone likes Star Wars, he probably hates the other movie, and the other way around. So if the correlation is 1, that means that if the person likes Star Wars, then probably also it will like this movie. So this is already interesting to us, but it is not enough. At first we have NaNs. I simply drop them, calling the drop Na, and in place equals true. So now I only have those which actually have a correlation. But then there's also one important point which I already mentioned. This is a high correlation, that's true. But actually, how many people have actually rated and seen this movie? This currently is not shown here, and that's why we need to be careful when we want to evaluate whether this is very a good indication or not. And this is why, if I go down there, just a second here, I join my other table to the one we have here, to the correlation, just to see what is actually the count for this movie based on which then the correlation is calculated. And the final thing I did was I just get rid of all the movies which have a count of less than 100. That's what I do here. Because then I only have movies where at least 101 people have rated it, and then I can take a look at the correlation, and because I said ascending equals false, I just sort it then based on the correlation column on the highest one. And the output here, to the end, the last data frame in here, is this one. And if you take a closer look, you'll see that, of course, similar to Star Wars is the movie itself, so because it's also part of it, so that's a correlation from 1, right? So the movie with itself, of course, has a correlation of 1. And you can actually also filter that out if you want. But more interesting, for instance, are the next ones. So we can see that Empire Strikes Back and also Return of the Jedi, which actually are both part of the Star Wars movies, actually also have a high correlation with the Star Wars, the original one, right? And this, of course, is very plausible, but also here it's done based on the recommender, our correlation. And then you can see there are other movies which have now a lower correlation, but still above at least 0.5, in this case for this one, for instance. And then it makes sense maybe to propose someone who liked Star Wars also this specific movie. And this can be done for all the other movies in the dataset as well. Of course, this is a very old dataset, but therefore I just found it and it's free, so I was able to use it. But you can also do this, the same approach for newer movies and series. And that's it, guys. So that's an easy introduction to recommender systems. Of course, if you think of Netflix and Disney Plus and Amazon Prime Video and so on, they have much more sophisticated movie ratings or recommenders, of course, because they might also implement other factors, like, for instance, the genre, right, for the movie and other kinds of things. So, but this is very interesting because it's easy to implement, and I encourage you, if you're interested in that, try it out yourself. And otherwise, thanks a lot for watching. If you have not done so far, please consider subscribing and also give this video a like. It helps a lot and also is a very nice feedback. So thanks, take care, and hopefully till the next video.